Okay, guys. So we are on page 2 of day 3. This is where we ended on Wednesday, and I'm recording this Wednesday night. Thought I'd go ahead and get this for you, just so we can maybe have it for my virtual kids. And so again, I'm not gonna. We had 2, 3, and 4 for homework, so I'm not gonna really get into those. Here's number 2. If you'd like to try and check yourself a little bit here to make sure you're on the right track. One that I did want to look at is one like number 1 or number 2. I just wanted to help you guys set this up. Just a little Algebra 1 review for those of you who don't remember. So when we use elimination, we try to destroy a variable. In other words, we lined up x over x, y over y, number over number, and we try to add these two equations together to get a variable to disappear, to destroy a variable, whether that's x or y. The problem is, if we were to add these right now, nothing would get destroyed. X plus x would be 2x. That plus that would be negative 2y, so x and y would both live. But what would happen if we multiplied, let's say, this bottom equation by negative 1? Because when we have a system, we can change the system as long as we multiply everything in it so that it all balances out. So watch what happens. I'm going to multiply this equation by negative 1. So my new equation would be negative 1x. Negative 1 times 3y would be negative 3y equals negative 1 times negative 4 would be positive 4. And then I'm just going to bring this top equation over. X minus 5y equals 20. So check it out, guys. Now we're able to solve this. X and negative 1x cancels. Negative 5 and negative 3, negative 8y equals 20 plus 4, 24. So, of course, you solve that for y. Take that, plug it back in to one of these. So whatever you get for y, I'll maybe plug into that, and then solve this for x. Same thing over here, except this time, I think we're going to have to multiply both equations. And the key here is we need a LCM. We need an LCM. That is a least common multiple. We need a least common multiple. So I'm going to look at, let's look at 8 and 3. Okay. Yep, 8 and 3. What's a least common multiple that these two share? Oh, 24. So that can get to 24. That can get to 24. The key is we want one of them to be negative 24. We need one of these to be negative 24. So I'm going to say let's multiply the top one. So how do we get to 20? How do we get to negative 24 using 8? Oh, that'd be negative 3. And if that's the case, if this is going to be negative 24x, then we need this one to be positive 24x. So the way we do that would be multiply by 8. So you end up with plus 21x, or y, equals negative 3 times 5 would be negative 15. And then over here, 8 times negative 5 will be negative 40. Y equals 8 times 9 would be 72. And now, of course, you're ready to add these. X's cancel. Take it from there. Okay. So, last thing we're going to do on day 3, guys. Last thing on day 3 before we jump into day 4, which is a short mini day. Hey, Proof Nation. And we know the first thing we need to do when we look at a proof, see what they gave us. Angle 3 is going to be equal to angle 4. So check it. That is going to be equal to that. Okay. So that's going to be equal to that. And hey, some of you guys are probably thinking, wait a minute. We got some vertical angle action going on here. I see that. And that's great. Remember, we want to figure out the topic. Figure out the topic of any proof. And once you figure out the topic, the reasons go along with that topic usually. It also looks like we're probably going to end up having, if that angle's that, that angle's that, that means, oh, these two angles are going to end up being the same. So another topic's going to be isos triangles. And if you remember, guys, back on the first page of day 3, we said we got a definition of isos and an isos triangle theorem. And look how both these end. Then the base angles are congruent. Definition is at least two sides are congruent. Whereas converse ends with, then a triangle is isosceles, and isos triangle theorem ends with, then the triangle is an isosceles. So we got to watch out. Converse is going to end with this. Definition and theorem is going to end with congruency, either sides with definition or angles with theorem. So those are kind of our two main things here. So let's get to it, guys. I'm going to do this first one with you guys, and then I'm going to let you try the one on the bottom here. So first one, we just got a straight up statement. Straight up statement. Angle 1 and angle 4 are vertical angles. Boom, boom. You guys know it. That's definition of vertical angles. We love it. Now, if there are vertical angles, that leads directly into 1 being equal to 4. And remember, what always comes after the definition of vertical angles? Followed by the vertical angle theorem. Theorems usually tell us congruency. Theorems usually are attached to equals. Definition is usually attached to either like a math statement or a straight up statement. Now, here's where things get a little interesting. We went from 1 equals 4 to 1 equals 3. It's kind of weird. Where did that come from? Oh, wait. If 3 equals 4 and 1 equals 4, cut out the middleman, then 3 equals 1. My favorite property. What's my favorite property? Transitive. That's what's up. Yeah, so if 3 equals 4 and 1 equals 4, cut out the middleman, 3 equals 1. That's a good old transitive property. Now look at what we're saying. We're saying, okay, now angle 1 equals angle 3. So we're talking angles. Okay, so angle 1 and angle 3, those are our base angles. We're saying if our base angles are equal to each other, therefore, we have an isosceles triangle. Now wait a minute. That's the conclusion. Which one is that the conclusion for? We were just talking about angles. Check it out. Definition, at least two sides are congruent is the conclusion. That's not right. Theorem, the base angles are congruent. Okay, angles, but that's not our conclusion. Our conclusion is it's isosceles. So, then a triangle is isos. That's the converse of this, but that has to do with sides. We're talking angles. If the base angles of a triangle are congruent, which we just proved, then the triangle is isos. Base angles are congruent, triangle's isos. We're looking at the converse, isosceles, triangle theorem. We love it. And so the converse isosceles triangle theorem, and from here we can say, okay, JK, this side right here, is congruent to KL, this side right here. We can say that, hey, if these two angles are congruent, this side and this side are congruent. So if we got sides are congruent, flash back to our first page, sides are congruent, we're talking triangle is an isosceles, then at least two sides are congruent. There's our conclusion. That's definition of isos triangle. Whew, that was a good one, guys. That was a very good one. So I'm going to let you guys try this bottom one for me. Try this proof right here, and let's see what you guys can do. Let's see if you guys managed to stick the landing with this first trifecta. So we were told 3 plus 2 equals 180, so immediately I'm thinking 3 plus 2 is 180. I'm thinking supplementary for sure on our topic. So that's going to help. And usually with supplementary, a lot of times we see the old gang come with it. Definition of a linear pair, that's just straight up the statement. Followed up by, well, if it's a linear pair, that must mean it's supplementary. That's the conclusion to the linear pair postulate. Now the conclusion to the definition of sup is that if these angles are sup, then they're going to add up to be 180. Hey, so let's see. Hopefully you guys were good on that. Now we're told if 3 plus 2 is 180, and 1 and 2 are a linear pair, and 1 and 2 are supplementary, then 1 plus 2 is going to be 180. So again, 3 plus 2 being 180, not really connected to this, but now if 3 plus 2 is 180, and 1 plus 2 is 180, cut out the middleman, couldn't we say that 3 plus 1 would also be, or 3 and 1 would also be congruent here? Because obviously they both add with 2 to be 180. So we can say 3 and 1 congruent based off my favorite property, transitive. Now, 1 and 3. Ooh, those are base angles. Now, if we've got angles, these are base angles. That leads into being able to say, hey, if these are equal, we got an isosceles triangle. So in other words, we got math leading to words. We got math to words, which means we're dealing with, you guys already got it, a converse of the isosceles, and because we're dealing with angles, isosceles triangle theorem. We know definition of isosceles has to do with sides. And speaking of the definition, because of this, because these angles are congruent, 1 and 3, we know that AB is going to be congruent to BC. And if we're talking sides being congruent, that's the conclusion to the definition of isosceles triangles. Great job, guys. So for your homework, and again, we're not done. Join me in the other video. We're going to have day 4. But HDub for day 3, just going to be our 6 problems on the practice multiple choice. You get to see those. This is on page 4. You get to see these in action. Hopefully on Friday we'll get to make sure we got these. So that will do for day 3. Join me on day 4 here in just a second.